This is PreCalculus 12, Chapter 8.5. We're going to be looking at Pascal's triangle. So what we would like to do is notice some patterns. And we're going to call this row N. So what's the first thing we notice? Well, we can see that the outside edge only contains ones. Next, we want to notice another pattern. Here's a simple one. We can see that this is increasing by 1 and increasing 1 in this direction. Okay, so we've taken care of this, we've taken care of this, we've taken care of this, and we've taken care of this. So we'd like to notice any other patterns. If we look sideways, there's really no definite pattern. But if we're always considering going down, we can see that this is 1 plus 3 is 4. And 3 plus 3 is 6. So let's try that on the next one. 4 plus 6 is 10. 5 plus 10 is 15. So we can assume that that's the pattern for now. 10 plus 10 is 20. We said the outside is always 1, and we said the next number is increasing. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. And 15 plus 6 is 21. So each number is the sum of the two numbers above. So the two numbers above, the two numbers above, the two numbers above. Can we see any other patterns? Well, I see 1, 4, 6, 1, 4, 6, 1, 5, 10, 1, 5, 10, 1, 6, 15, 20, 1, 6, 15, 20. So we could say it's symmetrical left to right. Or we could just say it's horizontal flip. Okay, so 1, 8, 1, 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. And then we said it was symmetrical, so we just copy 56, 28. So it doesn't take long to construct Pascal's triangle, up to 9 rows, even 10 rows. We do want to note that there is a relation between Pascal's triangle and combinations. So n choose r has the same value as the n plus 1th row and the r plus 1th term in that row. If we have large values for the row numbers, we can avoid computing a large triangle, and we use combinations to do this. And we have to look at the ordinals. Okay, the first row and the first term, we have 0, choose 0. That's 1. In the second row, we have 1, choose 0 for the first term, and 1, choose 1 for the second term. And let's just illustrate this further. In the fourth row, it's 3, choose 0, and then 3, choose 1. And then over here we have 3, choose 2, and then 3, choose 3. So the ordinal is 1, 2, 3, 4, and this is the third row. So we're decreasing the ordinal by 1, and we're decreasing the ordinal for the term number by 1. So these are ordinals. So we have, for this 8th term in the 12th row, we have 11, choose 7. That's the same as writing 11, 7 in brackets. This is 330. And to get the 10th term in the 12th row, it's 11, choose 9. We decrease it by 1. 11, choose 9, and that's 55. So everything's pretty simple. However, if you want a challenge, we can write the construction of a term number. Let's say this term. So this term is 4, choose 1. So 4, choose 1 is 3, choose 0 plus 3, choose 1. 4, choose 1 is 3, choose 0 plus 3, choose 1. Now, if we want to use this in variables, we can say n choose r equals n minus 1 choose r minus 1, because this is 1 smaller than this is 1 smaller than this. And then we have, again, n minus 1 choose r. So this is 1 smaller, but this is the same. Now, if you want a challenge, what you would like to try to do is write a piecewise function to perform this calculation. And the reason why you need a piecewise function is this formula only works on the inside terms. It doesn't work on the outside terms. Because if we look at this term, this would be 4, choose 0, and we have to do 3, choose negative 1, which is here, and it won't handle that. And again, if we try the end one, 4, choose 4, we'd have to have 3, choose 4 over here, but we can't do that. So you need to write a piecewise function. So n choose r equals, and you need 3 pieces. And the first piece, n minus 1 choose r minus 1 plus n minus 1 choose r when, and sorry, I'm going to have to go down here. R is greater than 0 and less than n. And then you're going to have to figure out 0 and what happens when it's n. And these are commas. And that completes this lesson.